Okay, it's been said there are two different multiplication between the vectors. One was dot product, we just talked about it. Another one is cross product. So once we take the cross product of two vectors, we will get another vector. This is the difference between the previous one. So we are showing the cross product with this cross sign, and this is also called vector product because, as I told you, once we take the cross product, we will find another vector. And the cross product is only defined for three-dimensional vectors. You cannot apply it for two-dimensional or others. Okay. So how can we apply this cross product? How can we calculate it? Here are two vectors are given with the components a1, a2, a3, b1, b2, b3, and this is how we can find the vector product a cross b, a2, b3 minus a3, b2. This is the second component, this is the third component. So as you can see, it can be really complicated to memorize this one, but you don't have to memorize it. You just need to know that this formula is coming from the determinant of two vectors with the standard basis vector. So what does it mean? This vector product is the same as the determinant of ijk vector, the components of the first vector, the components of the second vector. Once you take the determinant of that, you can find exactly this formula. Okay, to be able to find that, let's remember what was the determinant of order 2 by 2 matrices. If you have 2 by 2 matrices, the determinant of this one is easy. What you need to do is just multiply these diagonal elements, a times d minus b times c. Multiply the other diagonal, okay? And subtract them. For example, 2, 1 and minus 6, 4. What is the determinant of this matrix? 2 times 4 minus 6 times 1, which is 14, okay? Once you know that, you can easily find that one because we will be using the cofactor expansion to be able to find 3 by 3 matrices. For example, you have 3 by 3 matrix here. You are trying to find the determinant of that. According to the cofactor expansion, we are dealing with the first row. The first element a times just close the related row and column, okay? And if you do that, the remaining one's determinant is gonna come as a multiplication near that. So a times E, F, H, I. You know how to take the determinant of that one. E times I minus F times H. So it's easy. Minus B times close B column and B row. The remaining D, F, G, I. D, F, G, I is coming. And after that, the last one, plus C times. So the sign is plus, minus, plus. Don't forget that. C, close row and column, that belongs to C, the remaining D, E, G, H, right there, and just calculate that one. And this is the same as the cross product multiplication. Either you can, memorize and apply, or you can find it with the 3 by 3 matrices. For example, for that one, so we are starting with 1 times, close the row and column, the remaining 0, 1, 4, 2, right? 0, 1, 4, 2. And 2 times, close the row and column, the remaining 3, 1, minus 5, 2. And minus 1 times, close that, 3, 0, minus 5, 4. And the sign will be plus, minus, plus. And the determinants of this one, 2 times 0, 0, minus 4 times 1, minus 4. So this will be 1 times minus 4. And here 3 times 2, 6, minus 5 times 1, this will be plus. 3 times 4, 12, minus 0. The result will be minus 38. Okay, this is the 3 by 3 determinant finding, and you can use this idea for the cross product. And one of the most important properties of the cross product is it is orthogonal to both A and B. You know that once you take the cross product, you are finding another vector, okay? And you have two vectors, A and B, and the one that you found will be orthogonal to both A and B, okay? And you can do the proof of this one by using the dot product. if these two vectors are orthogonal, you know that their dot product has to be 0. Once you take that, you will see that it will be 0. And you can do the same thing for b vector, and you will find the exactly same 0, because the cross product will be orthogonal to both of the vectors you take. And according to the right hand rule, you can find the direction of the cross product. What you need to do is, if a and b is here, just use your fingers on your right hand and curl in the direction of a rotation from A to B, and your thumb is gonna show the direction of the cross product. Okay? And the geometric meaning of the cross product, once we come to that, you know that for the dot product, we said that the dot product is, you can find the angle between the two vectors. It was length of A times length of B times cosine theta. And in here, the length of the cross product is the length of A, length of B, sine theta this time. Okay? And from this idea, we can see that when theta is 180, it will be 0. So the cross product will be 0, which means that if two vectors are parallel, which their angle between them is going to be 180, and you can get their cross product 0. So if two vectors are orthogonal, check their dot product if it is 0. If two vectors are parallel, check their cross product if it is 0. Okay? You can find what kind of vectors you have by using these ideas. And this is the simple proof for that one. As I told you, theta is going to be either 0 or pi, and if you apply it from there, you can see that the length should be 0. If the length is 0, the cross product should be 0. Okay? And another thing about the cross product is you can find the area of the parallelogram by checking the length of the cross product. Remember the projection. Once you look at this plot, you know that this the projection of B onto A, you can find in here, right? And the projection of B onto A is the scalar projection, B sine theta. And the area of the parallelogram is the base times the height. So it will be, the base is the length of A times length of B sine theta, which is exactly the length of the cross product. And this will give you the area of a parallelogram. Okay? So area is the length of the cross product. The length of the cross product is equal to the area of the parallelogram determined by A and B. Okay, remember that. This is also a very useful identity for you. This is just one example. In general, I am asking this very simple, similar question in each exam. Three vectors are given, P, Q, R. And you are trying to find the area of triangle that is formed by P, Q, and R vectors. Actually, these are points. Firstly, you need to define these vectors from P to Q, P to R. You can define P to Q vector, P to R vector. And you are trying to find the area of the PQR, which will be the half of the area of parallelogram that will be formed with PQ and PR. This is the idea, okay? And firstly, let's define our vectors. How can you define a vector between 2 points? You are taking the difference of the components, right? We talked about it in the last class. So PQ vector will be minus 1 minus 2 minus 3, 3 minus 1, 1 minus 3, sorry, minus 2, 5 minus 4, 4 minus 5, it's going to be minus 1, okay? And form the PR vector, take the cross product of them, and you will find that. And you know that this length of this cross product is going to be the area of the parallelogram. So we find the area of the parallelogram by taking its length, and the area of triangle is exactly the half of this parallelogram. That's why we are dividing this into 2, and we can find the area of this triangle. I will ask one question as an homework to you this week. Make sure that you understand it. If you will not understand it, I can explain to you next week on Saturday, our online class. Okay? And for the standard basis vectors, the relation with the cross product, you can see that the I cross J is going to be K, J cross K, I, K cross I, J. But once you reverse the order, you can see that this is going to be minus K, minus I, minus J. So you can easily see that the cross product is not commutative, also it's not associative. Okay, so what kind of rules it can apply, you can see it in the theorem. Just for your information, you can check that out, but you don't have to memorize all those. And another product, triple product, is kind of the combination with the dot product and cross product. It is A dot B cross C. It's called a scalar triple product, which means that once you take a B cross C, there will be a vector. A is a vector. Once you take the dot product, you will find just a scalar, just a number. And what does this number mean? It means the volume of a parallelepiped. So, firstly, how can you take this triple product? Here you go. You need to write the components of A, components of B, components of C. Take the determinant. You know how to take the determinant. We just talked about it. Take the A1 times, close that, the determinant of the remaining. A2 times, close that, the determinant of the remaining. The sign will be plus, minus, plus. Okay? With the same idea, make sure that you know how to take this determinant. And if A, B, and C is given like that, you can see that the volume of this parallelepiped is gonna be the length of the triple product. Okay? Now that this is how we can find the volume of this parallelepiped, this is what we call, is gonna be the length of A dot B cross C. That's why we use it for the triple products in general. And this is the general explanation about that property. And another property I want to show it from in this figure. You know that B and C are in the same plane. A is not in the same plane. So B and C is in the same plane. A is like staying like that. But if A is in the same plane also with B and C, so if they are on the, for example, XY plane, all of that, we call them coplanar. And by using triple product, you can check that if the given three vectors are coplanar, which means that if they are staying in the same plane or not. How do you do this? You will check this volume. If this volume is 0, you can say that these vectors are coplanar, which means that they are in the same plane. Okay? Here you go. Use the scalar triple product to verify that these vectors U, V, and W are coplanar. And the application is easy. Just write the components of the first one, second one, third one, which is 1, 5, minus 2, 3, minus 1, 0. There is no K component. For W, 5, 9, minus 4. Take the determinant of this one. Make sure that you understand that part. And check that if it is 0. If it is 0, yes, they are coplanar. Okay? And these are the homework suggestions for you. I will assign your specific homeworks today.